Okay, guys, so here we are. We're going to talk about wind today. So, yesterday we talked about pressure. So, today we're going to continue talking about pressure, and then we're going to talk about how differences in pressure can cause it to be windy. So, our learning target for today is I can calculate the gradient of air pressure. We did gradient back when we did mapping. I can describe land and sea breezes. So, we're going to talk about these two things. And I can compare and contrast high and low pressure. So, yesterday we talked about what pressure is and how you can make it higher or lower, and that inverse relationship with temperature, humidity. But now we're going to kind of add on to that. So the next few lessons, everything's going to kind of be adding on. So make sure as we go through these that you understand everything before you move forward, because if you miss something, then you're going to have a hard time later. Okay. So I just want you guys to take a look at this map. I know there's a lot on here, but wind is going to happen whenever there's a big change in pressure. Yesterday we talked about isobars, and we said that those were lines of equal pressure on a map. And I want you to just look here, okay, at this L, this low pressure system, and notice how close together all of these isobars are. So as somebody who looks at a lot of weather maps, what I know that means is that it's very windy. Okay, so here's another, and you can see this L here is moving. Okay, it's moving up. This is Superstorm Sandy. Again, you have these, we know it was very windy, and you have these isobars very, very, very close together. So we're going to talk about what wind is. So wind is caused by differences in air pressure, often caused by changing temperature or water vapor content, also known as humidity. So just to review some of these concepts, if we're thinking about changes in temperature, how could we cause a low pressure? So how could we lower the pressure? Remember, these are all inverse relationships. So if I want the pressure to lower, then I'm going to increase the temperature. What changes in temperature would cause a high pressure to form? Again, it's an inverse. So if I want the pressure to increase or become higher, I need to lower the temperature. Changes in humidity would cause a low pressure to form. Same thing, it is an inverse relationship. So I am going to increase humidity, and then causing high pressure, we are going to decrease humidity. And this is all going to come up again later when we talk about types of weather associated with high and low pressure. So these are important things that we want to remember. So pressure gradient is the change in air pressure over distance. So the closer the isobars are, the higher the pressure gradient is. This is exactly the same as calculating gradient for a topographic map. So the higher the gradient, the higher the wind speed, just like when we looked at topographic maps and we saw a high gradient meant a steep slope. Okay, so now we have two examples here. Here I have a difference of 12 millibars. Here I have a difference of 8. Both of them are 100 miles apart. So this one here is going to have a steep pressure gradient, 12 millibars per 100 miles. So this has higher wind speeds. This is going to have a gentler gradient, 8 millibars per 100 miles. This will have lower wind speeds. So farther apart the lines are, the less windy it is. Closer together, more windy. And then we want to talk about how we measure wind. So we measure wind using instruments. Remember, I told you before on a test, it's often, you're very likely to get a question about what type of instrument we use. Easy question to get right. So for wind, we use an anemometer to measure wind speed. So this is how fast the wind is going. An anemometer has metal cups that rotate in the wind. The stronger the wind, the faster the cups turn. So here's an anemometer. You see you have these cups here. As the wind is blowing, these are going to rotate around, and it will, in this example, the digital screen, it would show up with a wind speed. Wind can be measured in miles per hour or knots. 1 knot is 1.15 miles per hour. So here's another example of an anemometer. And then also I have a wind vane. So a wind vane measures wind direction. So wind direction can be found using a weather vane. The arrow or pointer turns to point into the wind. This weather vane is pointing south, so a southerly wind is blowing. Okay, so it's pointing into the wind. And winds are named by the direction from which they blow. So where they're starting from, okay, that's how they're named. So this wind started in the south. The wind is actually moving this way, okay, but we name it about where it starts. Some examples of wind directions. Now, you don't have to necessarily memorize some of these in-betweens, but just in case you're curious. So obviously we have our compass northeast, south, and west, northeast, southeast, southwest, northwest, but then in between we have other directions. So in case it comes up, okay, here I have north of northeast. That's because this direction is closer to north than it is northeast. Okay, this is east of northeast because it is east of the direction northeast. This would be east, southeast, south, southeast, south, southwest, west, southwest, etc. Okay, so in our notes, we would have had these arrows labeled. So if you look at these, what direction is the wind blowing? So remember, we label from where we're coming from. This is coming from the west. So this would be a westerly wind. This wind is coming from the east. So this would be an easterly wind. Okay, so we're going to look at this diagram, and if we were in class, I would have you kind of take a look at what this is and gather your thoughts. So take a second, look at what's happening here. All right, so some things that we want to notice about this diagram. So this is a high and a low pressure. There's a city here. The H, we notice the air above is sinking, okay? We notice the air is moving away from the H, or the high pressure. It's also moving in a direction. For this low pressure here, we can see the air is rising above it. We see clouds here. We can see that the air is moving from the H outward and into the L. And this is going to be important later. So wind always moves from areas of high pressure to areas of low pressure. Okay, so what we also want to see here is that we have a cooler air right where this high pressure is, and we have warmer air here where this low pressure is. So this air is sinking, moving towards the low pressure, which is then going to rise, and later it's going to form clouds. So we kind of went over this. So we want to think about how low pressure center forms, thinking about things that affect pressure. So yesterday we said that lower pressure, okay, you're going to have warmer temps and or higher levels of humidity. Okay, so here are the characteristics of a high pressure. So this is something you're just going to have to memorize. So high pressure is associated with cooler, sinking air. And now it doesn't have to be cold. And it says cold here. That doesn't mean that it's 30 degrees. Okay, that means it's cooler than the air below it. All right. So I don't want us to get confused, because you could have a high pressure and you could have a day that's 80 degrees. It just means that 80 degrees is colder than the air surrounding it. So it sinks, it rotates outwards and clockwise, okay, in the northern hemisphere. And the cooler air sinks, creating clear skies we associated with high pressure systems. So when we have a nice sunny day that's clear, we generally associate that with a high pressure system. And another name for high pressure systems are anticyclones. All right, and the next one, if we wanted to draw a high pressure system, we would be looking at an H, okay, and we said outward and clockwise. So as long as your arrows are pointing out and they're going in the right direction, that's fine. No one's going to really stress about it, but this is the kind of thing that you could be asked to do on a test. All right, and then low pressure is pretty much everything is opposite. I have warmer. Okay, again, it's not necessarily hot, warm. It's just warmer than the air surrounding it. So it is rising. As it rises, it cools, condenses, forming clouds. It rotates inward and counterclockwise in the northern hemisphere. And another word for low pressure systems are called cyclones. Okay, so if I have a low pressure system, I have it drawn here, but I would be going inward. Okay, I would be going counterclockwise. So this low pressure system is associated with any kind of large storm system, so like a hurricane or a nor'easter, but also we have storm systems in the United States called mid-latitude cyclones, also low pressure systems. A lot of times when you see like a rainy event, you have some kind of low pressure system somewhere associated with it. Okay, so we're going to talk about now how this applies to the ocean. So this idea about high and low pressure and this idea about warmer and cooler surfaces. So why does the air blow cool wind from the ocean during the day? And it has to do with pressure. Okay, so if we think about the temperatures of the water and the land, okay, the water is going to be cooler, the land is going to be warmer. So cooler air tends to be associated with high pressure. So if we have water here, right? And then land, so this is cooler. So high pressure going to a low pressure because this is warmer. Okay, so during the day, the warm land heats up, or the sand heats up, becomes much warmer than the ocean. So you have this localized, and this is very localized to just that ocean area, that beach area, but you have a high pressure local around the ocean and then a low pressure local over the beach. So the air is going to move from high over the water to low, so you get this nice cool breeze off of the ocean. So we have these two things we're going to talk about. We have land breezes and sea breezes. So we just talked about sea breezes. Remember, when we name winds, we name them based on where the wind is coming from. So if it's coming from the ocean, it's called a sea breeze. Here's a diagram of what I was explaining. You have a high pressure, okay, cool sinking air. You have warm or hot land rising, creating the sea breeze going from the water to the land. Okay, and then we have land breezes. So notice we have changed to nighttime. So now this is going to happen at night when the land cools down. Okay, if you've been to the beach at night, the sand gets pretty cold. Depending on where you are, it may be colder than the water. So now you're getting a reverse. You're getting a localized high pressure over land because it's cooler, a localized low pressure over the water because it's warmer, and you get a breeze from the land to the ocean, and that is called a land breeze. And again, we name things based on where they start. All right, so that's pretty much it. So what we want to remember is these ideas about the highs and low pressures, how they form. Calculating gradient of air pressure, you just want to be able to use that formula. It's in the reference table for you. Describing land and sea breezes. This really takes into account all the things we talked about. So that high pressure being associated with cooler sinking air, the low pressure being associated with warmer rising air, and how the wind is going to blow from a high pressure to a low pressure. So hopefully this helps you guys understand wind and how it forms and why it forms. And I will see you guys in the next lesson.